So our next speaker from Siena is Jan Straznicky, who is Senior Director of Product Line Management, and he will talk about unleashing the edge advantage.
Okay, so as mentioned, we'll get started early. Maybe we'll get to coffee early as well. So what I wanted to spend the next 20 minutes talking about was sort of along the same lines as the previous session about, subscriber edge and what that actually means, not necessarily from a security perspective, but from a network optimization perspective, and some of the tools that exist today and some of the things we're working on, which sort of enable a lot more efficient transition of subscriber and service termination into a consolidated, converged approach. So, dovetailing on all the discussion around AI and the traffic generation that the network is going to have to withstand, we still have the reality of what's going on today in the network, and that is a rapid continual growth in terms of the amount of traffic demand based on the applications that exist today, right? The reality is the network or the entire world is really dependent on higher and higher speeds. So the evolution to broadband is basically now at a point where we're completely reliant on it, right? And as a result of this broadband reliance, there's a whole new set or a continual evolution of the set of applications that we need to support on the network. And the reality of that, those different applications is that they all bring their own unique requirements to the network, right? They bring bandwidth requirements. Some are very, very hungry. There are some applications which are very latency sensitive, and there are some which are both, right? So the impact on the network is very significant depending on the type of applications that you have to design around. And the reality is as you build that next generation network, focusing on some of the tools that are available today and pushing that subscriber intelligence closer to the edge, being able to be more flexible in the way you deploy services and how you interconnect the different service termination functions, and being able to do it at scale, right? Because the reality is as we move towards more of a converged network, all of those different endpoints end up on the same network, so that infrastructure needs to be optimized for scale, in addition to all the flexibility that we're talking about as well. But if we look at how service networks and the various service edges which exist today, they tend to be very focused on the types of services that they've been designed to provide, right? So the enterprise network and the service delivery network for those types of services are really designed around the provider edge model, where you have loads of service termination points residing back in the network, and they stitch together different customer locations, ultimately to provide site-to-site VPNs, but eventually down the road, internet connectivity as well. Then you have on the top right the mobility network, which is its own complete different approach, where you still might use potentially in the middle the same IP MPLS network to provide transport, but the service termination point is really that gateway function that sits back in the network. And even with 5G, where we start introducing various UPF functions, even those tend to be distributed in suboptimal ways. And then on the bottom, when you look at the residential side, this is again potentially using a similar metro IP MPLS network, but the aggregation part of the network, the fiber access network, the subscriber termination point, all of the infrastructure on the back end to do subscriber authentication policy, all those things are different, right? So you see a lot of the infrastructure to realize these different services are relatively inflexible. They're kind of rigid, they're fixed anchor points. You have the same functionality, that control plane, user plane functions duplicated in multiple different isolated siloed instances. And for the most part, they don't necessarily have the tooling or the instrumentation available for delivering these functionalities and services via automation. So a lot of the functions that have to go on to make these networks work are mostly manual, right? So with the goal of trying to become much more flexible and the ability to potentially address more and more scale in the network, more and more capacity in the network, what it is do we want to sort of evolve to? And that's where we tend to look at what's possible with an evolved service edge and how do we get there? Well, ultimately we want to be able to handle that growth in capacity in a very flexible way. And we want to be able to do that dynamically. We don't want to have to go into the individual network and spend months kind of planning the growth and all that kind of stuff. We want to be able to do these things on the fly and potentially upgrade existing services very streamlined. We want to be able to also utilize the same infrastructure for all different service type networks. So what does that actually mean? That means at all different points in the network, you need to be able to make the traffic or the network aware of the different types of applications that are on there. Typically, that's done through slicing. And so in order to do that kind of concept, you need to be able to be aware of what slices are on the network, but also have the functionality in the network to steer to those individual service termination points through some sort of mechanism in the network as well. You want to be able to have that resiliency from a service perspective, not located way back in the network, but a lot closer to the network, and use the tools within the various layers of the network to realize those. And the final thing is you want to make sure that the network itself can support a distributed services mix, right? So how do we get there? Well, the first thing, looking at some of the existing infrastructure tools that are available, and we've had multiple conversations or sessions talking about this in the parallel session and yesterday, is really focused on a dynamic, programmable, and automated underlay network, right? That's one of those key infrastructure pinpoint or points or pillars that we need. To help solve the scale problem and the ubiquity problem and the flexibility problem, you want to leverage a unified service overlay, right? You want to be able to use the same signaling mechanism for one service type, make that applicable for all the different service types. You want to be able to assign traffic, customer traffic, whether it be VLAN based or subscriber session based, however you have, whatever tools you have, you want to be able to use that to drive your session steering. So using more of a policy-based approach to steer traffic to the individual service termination points in the network. To handle the requirements around performance on an application level, you also want to be able to take advantage of different form factor forwarding planes. So being able to use both silicon-based and compute-based user plane functions, and be able to make sure that the service functions that are delivered using those user planes are identical, but take advantage of the economics that are most optimal for the deployments and the applications you're trying to serve. And the final is around access network consolidation. So being able to leverage similar hardware for all the different access types, all the different service types, right? So not be having to deploy 3 different platforms to do the 3 different service edge functions. Why not be a lot more flexible in the way you allocate resources, the way you provision those devices to be able to handle all different service types and service termination points on the same platform. So stepping through those in a little more detail, when we look at the first point around the dynamic and programmable underlay, right? This whole conference is really talking about or initiated around MPLS and has evolved into segment routing. We've had a lot of discussion the last couple of days and the last couple of years about the benefits of segment routing. This is one of those use cases and obviously the critical use case for why this evolution makes sense. Part of the scale challenge we have to manage is that we've had so many different protocols in the network that effectively bog down the performance of the network because we have multiple functions needing to interact with each other and potentially cause scaling limitations and provisioning bottlenecks as we try to roll out service. So segment routing really helps us with helping us address that large scale problem. And it also helps us with spanning multiple domains when it comes to deploying an underlay service. Baked into it, we have obviously all of the load balancing and resiliency capabilities, and it's programmable, right? So because we are now at the source, we can use a policy-based infrastructure to effectively tune and change the destinations of all the different service types that we're trying to provision on the nodes. And we have all of the instrumentation that's tied to path performance end-to-end using various OAM tools to feed back to your path computation infrastructure to effectively re-optimize continuously based on the performance of the network, how these different slices get steered across the converged infrastructure. And using techniques like FlexAlgo to do per slice specific tuning and SLA enforcement, right? That whole concept of being able to be both slicing and planar diverse is very advantageous as we try and utilize a converged network infrastructure to do service termination. And the final point is around traffic engineering. So being able to, on a per application or per service basis, we all know the advantage of TE, being able to flexibly apply that to particular slices, whereas some slices may just be, best effort type traffic. We can afford to just rely on traditional shortest path calculations, whereas now you can also add additional flavors of traffic engineering. Could it be based on latency? Could be other use cases which may be driving that. So that's sort of point number one around evolving that service edge is the underlay. If we move to the overlay, again, we've talked previously about EVPN and the benefits that it provides. From my perspective, that helps with scale on a number of different things. By consolidating the service overlay, you get rid of protocol or compute intensive overhead protocols, signaling protocols like targeted LDP, which effectively can limit the overall size of your network because of those individual scaling limitations. And the lack of ability to sort of segment that network in an optimal way to reduce that kind of scale. So introducing a single common overlay allows us to take certain protocols out of the network, which were scale challenged to begin with, and provides us more flexibility and standards or protocol-based resiliency functions, both on the uplink and the downlink, that allow us to do a lot more simplified subscriber mobility use cases, right? The whole ability to introduce Anycast distributed gateways, that kind of functionality was not something you could do in a single protocol before. You had to stitch together a couple of different things, do a lot of testing to make sure that the two protocols interacted properly, or potentially three protocols interacted properly, before you could actually deliver a service. The reality of us taking that signaling protocol not only out of the network, potentially solves us a signaling problem that did exist, but now it also helps us ensure that the service termination point, which in a lot of cases from a subscriber perspective is the UPF, you've now reduced a significant scaling challenge on that platform, allowing you potentially to scale your UPF even higher, right? So at this stage, you can utilize the same technology to handle a higher number of services or subscribers on one platform. The other thing around security, typically we do a lot of these things using sort of split horizon and things like that, well, that's natively baked into the protocol as well. So, you're not losing anything that you had today by evolving in this direction. The next thing is around steering. And the interesting thing here is that traditionally, this is kind of what helps allow for the convergence, right? So being able to effectively, on that access point, be able to interface with all the different network types, all the different service types, and be able to steer individual services, and even at the subscriber layer, depending on whether it's a VLAN, depending on whether it's a subscriber ID through DHCP or something like that, orchestrate that steering function utilizing the examples in the two previous slides, the underlay and the overlay, to be able to steer traffic back to the individual endpoints, allowing you to sort of collapse those same functions on the same platform. Here is also where you potentially could make those slices or the steering function aware of the individual slices, right? So this extends not just to wireline, but also the evolution of wireless as we move into AGF. The next point was around the multi-form factor user plane. So, the idea that I have there at the bottom is that you don't really want to be trying to compromising the performance of the application based on what your user plane is capable of. You want to be able to tailor the user plane that you deploy based on your application needs and also the network infrastructure that you have available. So our view is that the same actual service termination function should be available regardless of whether that is based on a compute cloud pod or a actual physical ASIC. So whether or not you are using UPFs to terminate particular types of traffic in one part of the network or another, the functionality is the same, the integration is the same. It's just that the platform that you use to deliver that is optimized for the infrastructure you have available at that location. So again, making sure that the user plane is actually tailored to the application needs and not vice versa. And the final point was around evolved service edge around access and network consolidation. So the whole concept of universal aggregation, where you can use the same platform to deliver the entire suite of functions and services that you did before, whether it's a OLT function for PON, whether it's a business edge PE, whether it's a mobility cell site router or transport, or even if it's a user plane. Be able to use and deploy the technology on a single platform and be able to provide the steering and the slicing and all of those different policy infrastructure interfaces on the same platform, so that you're not having to deploy multiple platforms in the same location to do the different service terminations. You can use a single platform and architect that accordingly. So that would simplify the overall network rollout, the network planning, the sparing, all those things associated with, or you reduce all the things associated with having to deploy multiple platforms in a particular location for discrete functions. And the final bit is around integrating coherent and pluggable optics where required to drive natively into fiber or photonic line systems. The reality is as we pull things like dedicated transponder shelves out of the network, the capabilities of those plugs that you're putting in should be able to drive directly into the existing photonic line systems, be tunable as they would need to be to fix into either a fix or a flex grid photonic line system. But the reality is technology today allows you to do that on a routing platform versus what was previously possible. And what you see at the bottom is, on the left-hand side, the traditional model of deploying an OLT, deploying an aggregation router, deploying a transponder, deploying a BNG for user plane, you can now collapse that onto a single routing platform where you can use pluggable technology both on both sides of the optics domain, whether it be PON or whether it be coherent transport, and then collapse a user plane forwarding function on the same thing. So this is where I see a big advantage or big opportunity for operators as they evolve to really collapse a lot of functions onto the same infrastructure, deploy services the same way as they did before, but now save a lot of infrastructure. So I have 1 minute, so just to finalize, I think we covered some key aspects associated with evolving the service edge. We covered the underlay and what we need from that. We covered the overlay and how a unified service overlay solves a lot of scale problems in the network. The flexibility gets introduced with a slicing and policy-driven steering function. Being able to leverage the same user plane function, regardless of whether it's compute or whether it's silicon-based, gives a lot of flexibility to operators to tune the forwarding function to what the application needs and not vice versa. And the final opportunity or key aspect is around consolidating at the access network, being able to leverage pluggable optical technology on either side to really collapse a lot of functions onto the same platform. A lot of these infrastructure building blocks are already enabled or available in some form or fashion. What we're doing is now figuring out how to collapse those onto a single platform in order to make it easily deployable for operators. So with that, thank you very much.
Thank you.
Move to the break.